Process engineer Joe wants to improve his process output and decided to upgrade his tool with a Levitronics pump. Yet, what pump model should Joe select? The performance of the pump should match the requirements needed by the system. At the same time, Joe doesn't want to oversize. How will Joe find out how much performance his hydraulic system requires? The answer to this question lays in the system load curve. The system load curve is a representation of the required pump head to move fluid through a fixed hydraulic setup at various flow rates. A system load curve consists of a static and a dynamic head. Static head, also known as a vertical lift or geodetic head, refers to the difference in elevation between the inlet and outlet of the hydraulic setup. Static head is present whether the pump is operating or not and is plotted as the lower portion of the system head curve. Dynamic head, also known as friction head or friction loss, is the required pressure to overcome flow resistance. As the flow rate increases, there is a corresponding rise in system head. Dynamic head is influenced by elements in the hydraulic setup such as tubing length, tubing diameter, and further restrictions such as bends, valves, or filters. How does this help Joe to select the right pump? The system load curve is used in conjunction with the pump performance curves and can be overlaid on the same graph. The intersection between these curves indicates the maximum achievable duty point of each pump. Knowing the system load curve of this hydraulic setup and the flow pressure curve of the Levitronics pumps, Joe can easily select the right size for his application. Levitronics, better pumps for better yield.